Hello and welcome to section 3.6, Summary of Curve Sketching. In this section, basically what we're trying to get out of this section is trying to figure out how curves and their derivatives and all the values of like concave up and concave down and increasing, decreasing affect the graph and the original. So all of this is going to be kind of a review of what we've done so far, and it's also trying to remember what we did in pre-calc and all of that stuff. And so we're just trying with this one. The labor intensive is the part of getting the graphs, but what you need to focus on in this section is the fact that we really just need to know how the original graph and the first derivative and the second derivative react to one another. So like when we're at a maximum in the original function, we're looking at the 0 in the first derivative, and when we're looking at a maximum in the first derivative, we're looking at a point of inflection or something like that. And so that's kind of what you need to walk away from this section, not necessarily being able to sketch a graph that's not necessary for the AP test, but you need to be able to see how the original function, the first derivative, and the second derivative react to one another and how they are related, and that's kind of the key. So when we're doing this, it talks about finding the domain and the range of the function, intercepts, asymptotes, symmetry of the graph, and then locate the values where f prime and f double prime are 0 or don't exist. That's the key. And then try to get relative extremas from this. One thing that you need to remember is that there are slant asymptotes from time to time, and that is when we are dividing a function. When we take a function and something like x squared minus 2x plus 4, and we try to divide it by something that is just one power less than the top, and so that's where a slant asymptote comes up. And in order to do a slant asymptote, you have to do long division. And remember that we don't care about the remainder for the slant asymptote, we only care about the value there. And so that will help us get a better sketch of the graph. It'll also help us determine max and mins and all of that fun stuff that we're doing. So here is a way to kind of deal with the graphs, and it says analyze and sketch the graph of this function. So what I did here is you'll notice that when we're dealing with an interval, we don't fill in the f of x part. We don't fill in the f of x for an interval because we don't know exactly what's going on there. Now, how I got these things in this table are basically going through and doing the first derivative and the second derivative of this function. And so that might be something that you'd want to do just to kind of see what's going on. But you'll see as we practice these guys in class. So we kind of want to remember what is happening with this graph when we have these values. So we have this function where we're dealing with the x over the square root of x squared plus 1, or plus 2. And so when we have this, we would end up with our first derivative. Oops, I think I made a mistake. Our first derivative is positive, and our second derivative is also positive. This should be a positive. And make sure I didn't. All right. And so then if that's the case, then that means that the graph is increasing because of the first derivative, and concave up because of the second derivative. Now you'll notice that in this next one, when x is 0, that I get my 0, so that's an ordered pair, 0, 0. Here I get a value, some value here, and then over here in the second derivative I get a 0, which means that this is a point of inflection. And you'll see as we do these how this kind of works out. And then the last part, the last interval, how I broke this up was basically I took the first derivative, found the critical numbers, took the second derivative, and found any possible points of inflection. And the only thing that I found was this 0 value. And so that's how these tables are set up. And so then this last one here, I have a positive in the first derivative and a negative in the second derivative. So I'm still increasing, but this time I'm concave down. And so then we might need some more information from this graph. For example, we might want to do a limit to infinity. If we do a limit of this graph as x approaches infinity of x over the square root of x squared plus 2, we would find out that if I divide everything by x squared, which is really the square root of x squared, but all of this is under the square root now. And so if that's the case, then on top I get 1 over the square root of 1 plus 0. Well, that will be 0, which is 2 over x squared. And when I do my limit as x goes to infinity, you will see that I end up with a value of 1. If I do negative infinity, then one of these guys would be negative. So then now I know I've got horizontal asymptotes in this graph at 1 and negative 1. So if I'm going to quickly sketch a graph of this guy, well, let's see what's happening here. If I sketch a graph, I know that at positive 1, I have a horizontal asymptote. Actually, I'll use this green one. Positive 1. We'll call this positive 1 right there. Negative 1 will be about the same distance away. So there's my horizontal asymptotes. I know that I have a point of inflection at 0, 0 because of my table. And then from here, I am increasing as I go from 0 to infinity. I'm increasing but concave down, so the graph is going to probably look something like that. And then down here, I am decreasing and concave up. So if I could draw any straight line, that would be how the graph would look over there. And so just knowing how these graphs are dealing with one another will be helpful how the first derivative, second derivative deal with one another, and just kind of it will give us plenty of information about the graph. And so that's what we can conclude. And I also, just going back to the asymptote talk real quick, I knew there wasn't going to be a vertical asymptote because there was no way to make this bottom part 0. And so that's why I only went with horizontal asymptotes. So just be prepared. We'll talk more about this in class, but if you have any questions, please come to class prepared to ask them.